Hello, in this lesson we're going to solve equations using division. We're going to look at the multiplication property of equality. So in essence, we don't have any different goals from lesson 5.3. Our goal is still to isolate the variable and to solve and show a balanced equation, but we're going to look at how we use multiplication and division to achieve that goal today. Multiplication in algebra looks different than multiplication with whole numbers or integers. We remove the symbols that we usually use for multiplication. So we take away the x symbol, the raised dot, or the parentheses for the most part, and we have a coefficient and a variable basically stuck together. So this 5a means 5 multiplied to a. And this 9n means 9 multiplied to n. And that's very helpful to know because when we want to isolate the variable, we need to always ask ourselves, what are we doing to the variable? And for 5a is equal to 15, we're multiplying 5 times a. So in order to get rid of this 5 and isolate a, we're going to have to do the opposite operation, which is division. So we're going to divide by 5 on both sides of the equation because we know that 5 divided by 5 is 1, and 1 times a does not change the value of a. So that cancels, leaving us with a isolated, and then 15 divided by 5 is equal to 3. Same goes with 9n is equal to 72. We're multiplying 9 times n, so therefore we must divide it in order to remove it. And what we do on one side of the equation, we have to do on the other side. That gives us balance. So 9 divided by 9 is 1. That gets rid of it, isolating n. And 72 divided by 9 is equal to 8. In example 1, we see that we have 6 multiplied to m is equal to 48. Because we're multiplying to the variable, we're going to divide on both sides of the equation, canceling the 6's on the left-hand side, isolating m, and then 48 divided by 6 is 8. So we'll have m is equal to 8. If we want to do a check, we're going to substitute 8 for m in the original equation. So we're going to take 6 times m, which is 6 times 8, is equal to 48. And indeed, we see that we have a balanced equation. The check works out, so we know that 8 is the correct solution for m. For example 2, we have negative 4 multiplied to t is equal to 20. If you have a negative coefficient multiplied to the variable, then you need to divide by the negative coefficient. So we are going to divide by negative 4 on both sides. And that's because if you look at how this reduces down, negative 4 divided by negative 4 gives a positive 1, and we need to have a positive variable. So those cancel each other, leaving us with t is equal to 20 divided by negative 4, and that gives us negative 5. To check, we substitute back in the original equation, putting negative 5 in replacement of t is equal to 20, and we see that negative 4 times negative 5 is a positive 20, so we know we have the right solution for t. In example 3, we have a fraction that is being multiplied to x. So when you have a fraction being multiplied to x, you can ask yourself a very important question. What is the inverse or opposite of 2/3? Because what that does is it can help you to solve this question a bit faster. The opposite of 2/3 is its reciprocal, 3/2. If we look at this question, I can show you 2 ways that you can solve. The first way is the method that we've been using for whole number coefficients. So we're multiplying 2/3 times x, so therefore we should divide by 2/3. And that's totally okay. So 6 divided by 2/3 is what we will have to do, because 2/3 divided by 2/3 cancels out, that equals 1. So x is isolated. On the other side, we'll have to do this work on the side. 6 divided by 2/3 means that I have to put 6 over 1. And then because it's a division of fractions question, I have to flip 6 over 1 times the reciprocal, which is 3 over 2. And then I can cross reduce. I can divide by 2 and divide by 2, getting the result of 9. X is equal to 9. But I can go a little bit faster if I recognize right away that the inverse of 2/3 is 3/2. So what I could do is I could take 2/3 x is equal to 6, and I could multiply by its reciprocal. If I multiply by its reciprocal, I'm canceling, everything is becoming 1. And I multiply by the reciprocal on the other side. So it ends up going a little bit faster if I take a fraction that is multiplied to x and I multiply it by its reciprocal. And I will get the same result, but I'll save a little bit of time. Now, when you want to do a check with fractions, you do need to substitute back in that original equation. So 2/3 times 9, which we'll place over 1, is equal to 6. And then we try it, and we see we can cross reduce here with the 3 and 9, divide by 3 and divide by 3, and 2 times 3 is 6, and the denominator is 1, so 6 over 1 is the same thing as 6, so we know we have a balanced equation. For example 4, I'm going to show a couple ways to look at this question. One way is the way the book describes it, and another way is a little bit different. So if we look at d divided by 5 is equal to 20, first up we can see, well, this is a 1d. So what this actually could be looked at as is 1/5 times d, because we can move the variable out, and d divided by 5 is the same thing as 1/5 times d is equal to 20. And then again, what we have is a fraction that we can flip to its reciprocal and multiply by. So then we can multiply by the reciprocal, which is 5 over 1, and multiply by the reciprocal, which is 5 over 1. And so we would cancel our fractions, and d is equal to 100. The way that I go about it, even though I'm comfortable with 1/5 d, is I can look at what's happening to d. So I can ask myself, what's happening to d? Well, d is being divided by 5. So if d is being divided by 5, I can do the opposite. I can multiply by 5, and I can multiply by 5. And 5 multiplied means that I'm going to cross reduce. I'm going to cancel that out to be 1, isolating d, and 20 times 5 is 100. But it is a good thing to note, and it will be important in the future for us to see that d over 5, anytime you divide by a number, it's the same thing as multiplying by a fraction. So you may want to put a star by this example and try these methods when you're faced with a division question like this. D over 5 is equal to 1/5 times d. Just like cutting something in half is the same as multiplying it by 1/2. So x over 2, something divided by 2, is the same thing as multiplying it by 1/2. Now, if we want to do a check for this question, it's the same as we've always done. We substitute for d, so we take 100 where d is in the original equation, divide by 5 is equal to 20, and 100 divided by 5 is 20, so we have a balanced equation. We know that our solution is correct. For the do together, we have 7x is equal to 14, And so we see here that we are multiplying to x, so therefore we have to do the opposite, which is divide by 7 on both sides of the equation. These two 7s will cancel on the left, leaving us with x isolated, and that is our goal. And 14 divided by 7 is 2. For number 2, we have 3 multiplied to x is equal to 15. So because we're multiplying to x, we have to do the opposite and divide by 3 on both sides of the equation, canceling on the left, leaving us with x. And 15 divided by 3 is 5. Remember that to do a check, you're going to substitute in the original equation 3 times x is equal to 15, and you will know if you have the correct solution for your variable. For number 9, we have a fraction times r, so we have half times r is equal to negative 20. Remember that the opposite of a half is 2 over 1. So in order to eliminate this half, we can multiply by the reciprocal on both sides of the equation, canceling out on the left-hand side, leaving us with r. And then we're going to take negative 20 over 1 times 2 over 1. And we see the result here is negative 40. R is equal to negative 40. And when we do a check, we're going to take half of negative 40 is equal to negative 20. And we can see here that we're going to cross reduce, divide by 2, and we do have negative 20 equaling negative 20. For number 10, we have t divided by 4, which is the same thing as 1/4 times t. Or we can look at the problem as t is being divided by 4, so therefore I need to multiply, do the opposite operation. On both sides of the equation, I'm going to multiply by 4. This will cancel, leaving me with t isolated. 12 times 4 is 48. T is equal to 48. 11 and 12 help you practice the idea of that reciprocal. So we have 1/3, negative 1/3 times x is equal to 24. Well, the reciprocal of negative 1/3 is negative 3 over 1. So we can multiply by the reciprocal, and what that does is cancels out everything. We can see that this cancels the 3, and the 1s cancel as well, and the negatives cancel each other, leaving us with positive x. And then we're going to multiply 24 by the reciprocal as well. We can do that work over on the side. 24 over 1 times negative 3 over 1. This one we have to multiply 24 times 3. And it's a negative 3, so it's going to be a negative 72. X is equal to negative 72. And for number 12, the reciprocal of 2/5 is 5 over 2. So we're going to multiply by 5 over 2, which cancels, and multiply by 5 over 2. So y is equal to 12 over 1 times 5 over 2. We're going to divide here, cross reduce, divide by 2, and then we see that y is equal to 6 times 5. Y is equal to 30. Remember, if you're more comfortable taking one extra step to solve this problem, this is no worries at all. You can also say 2/5 is multiplied to y, so you can divide by 2/5 on both sides, which will result in you multiplying by 5 over 2 in the end.